Welcome to aminacademy.com. In linear algebra regarding homogeneous system of linear equation, let us do some solving problem. Look at this example. Use Gaussian elimination to solve the following homogeneous system of equations. Here this equation with 4 variables and 3 equation is given. We have to do some elementary transformation. By elementary transformation, the coefficient matrix can be reduced to row echelon forms. First you have to write the coefficient matrix like here 1, 1, 4, minus 1, 1, 2, and minus 1, minus 2, 4, and 3, 1, 1. Coefficient matrix is here. Here our aim is to get these 3 parts must be 0, where getting this 0, R2 operation R2 gives R2 minus R1, that is 1 minus 1 is 0, 1 minus of minus 1 is 2, minus 2 minus 2 minus of minus 1, that is minus 1, and 1 minus 3 is minus 2. So this first pivot becomes 0. Next we have to consider this becomes 0. For that R3 gives R3 minus 4 R1. R3 4 minus 4 into 1 is 0, and minus 4 into minus 2 of minus 1, that is here 2, like that, here 8, here minus 11. So next here also becomes 0. Then our aim is to get this is 0. For that R3 gives R3 minus R2, that is 2 minus 2 equals 0. Here 8 minus of minus 2 is 9, and minus 11 plus 2 is minus 9. So we got these values of zeros. Now easy to solve now. The rank of this matrix equals to 3. So the system with 4 unknowns has an infinite number of solutions, because 4 unknowns, 3 equations, so it's infinite number of solutions depending on one free variable. If we choose x4 as the free variable, here x4 is a free variable we are keeping as, and set x4 equal to c, free variable value c, then the leading unknown have to be expressed through the parameter c. The above matrix corresponds to the following homogeneous system. Here x1 minus x2 minus x3 plus 3c, because we are having here 3x4, that is x4, 3x4 is 3 into c equals 0. Next here 2x2 minus x3 minus 2c, because here x4. Next is here 9x3 minus 9c equals 0. From this we can get the last equation tells to solve this 9x3 equal to 9c, therefore x3 equal to c. That by using method of back substitution, use x3 c here, and c we obtain 2x2 equal positive x3 plus 2c, therefore x2 equal to x3 plus 2c, which is equal to 3c, because x3 is already c here, so c plus 2c is 3c, therefore x2 equal to 3 by 2 c. Now further back substitution for this, x1 equal minus x2 both that side is plus x2 plus x3 minus 3c. We are substituting 3 by 2c for x2, then x3c and minus 3c. Here it becomes minus half c. So we got x1, x2, x3 in terms of c. Therefore the general solution of the given system is given by the following formula. Here x is x1 minus half c, x2 is 3 by 2c, x3 is c, x4 is c. So c take out common, minus half, 3 by 2, 1 and 1, column vector. To obtain the particular solution xi, we have to assign some value to the parameter c. Suppose we are having value c, So c value is 4 means half of 4 minus half of 4 is minus 2. 3 by 2 into 4 is 6, and 1 into 4 is 4, and 1 into 4 is 4. So for keeping c equal to 4, we are having the set of solutions. Suppose we are giving c some another value, regarding that the value will change. Therefore solution is this one, minus 2, 6, 4 and 4. We will check the solution. x1 is half c, x2 is 3 by 2 c, x3 is c, x4 is c, but before. Reduces all the equation in terms of c is like, so of course this is equal to 0, because minus half c minus 3 by 2 is minus 2c, minus c is minus 3c plus 3c is 0. Like this, all satisfied. Next example. Here, let the matrix is given here with means 4 variables, 3 equations. Find the solution of the homogeneous system of linear equation Ax equals 0. Transform this coefficient matrix to the row echelon form. Here, this matrix first we have to write as it is. Now we have to get these values become zeros. For that, here first operation is R2 gives R2 minus 2R1. That is R2 minus 2R1. That is 2 minus 2 equals 0. So first row as it is we have to write. Second row is 0. Here also minus 2 minus of minus 1. So which gives here also 0. Here become 3, because 3 minus of minus 2 into minus 1 is 1 plus 2 is 3. Like that. Here for R3 we have to get this point is 0. For that we can get it R3, that is 5, minus 2R2, that is minus 4, minus R1, so minus 5. So 5 minus 5 is 0. Regarding other values we have to write regarding this total summation. Here therefore we got this areas 0 and more zeros are there. For that, since rank A equal to 2 only, because here this completely the last row becomes 0, so the reduced rank A is from 3 to 2. We have to consider 2 unknowns as leading unknowns and to assign the parametric value to the other unknowns, setting x2 equal to c1, x3 equal to c2. We obtain the following homogeneous linear system like 2x1, that is x2 is c1, x3 is c2 plus x4, then 3c2, because yeah, 3c2 minus x4. Therefore x4 equal to 3c2, and x1 is half of c1 plus c2 minus 3c2, which is equal, because we are substituting here from this we are getting these relations. Therefore the solution is x is half of c1 minus c2, then c1, c2, 3c2. In the view of matrix properties, the general solution can be also expressed as the linear combination of the particular solution. Means, look at here, x equal to this first solution, half c1, 0, 0 plus addition of this one is minus c2, 0, c2, 3c2. Like we can assign the c1 is taken out for this half 1, 0, 0, c2 is minus 1, because half minus 1 is half can be written as half minus c1 is here, look at c2 is minus 1 and c1 is half, because half c1 minus c2. Then like we can write other combinations also. Therefore the particular solution is x1 is half 1, 0, 0 and x2 is minus 1, 0, 1, 3. This is the solutions. From the fundamental system of solutions, you can get it x equal to c1 x1 plus c2 x2. Now this is from the parametric values of C1 and C2 we can get the solution of this system of equations. One more example. Here let a 3 into 3 order matrix is given. Solve the following homogeneous system of linear equation Ax equal to 0. Here explain why there are no solutions and infinite number of solutions or exactly one solution, which is there here. You have to get the solution. Note that any homogeneous system is consistent and has at least a trivial solution. Transform the coefficient matrix to the triangular or row echelon form. That is, we consider this. You have to consider to make this 3 as 0 by row transformation. Look at here. Then R2 equal to R2 plus 3R1. 3 plus 3 into minus 1 becomes 0. Like here, same row transformation, R2 plus 3R1 gives to here. Here, same, it becomes minus 3. Last one, R3, this also you can get it 0 by using, look at here, R3 is R3 plus 2R1. Here 2 minus 2 into 1 is minus 2, 2 minus 2 is 0, like 2 plus 2 into 1 is, that is 2 minus of 2 into 1 is 0, that is 4 here, then 3 minus 3 into 2R1, that is 2 into minus 1 is minus 2, that is minus 3 plus minus 2 is minus 5. So here next this should become 0. How to get it? That is, look at here, R3 minus 2 R2. Suppose we are substituting here, the row transformation is R3 minus 2 R2, that is 4 minus 2 into 2, that is 4 minus 4 is 0, minus 5 minus 2 into minus 3, it becomes minus 3, then it becomes here 0 minus 0, R3 is so this 0, here 4 minus 2 into 2, 4, that is 4 minus 4 is 0, minus 5 minus 2 into minus 3 gives 1 here. So we got row echelon form. Now the rank of A is key because 3 into 3 order, here this have triangular matrix here. There are no free variables. Here there is no free variables because all are available, that is minus x1 plus x2 minus x1 plus x2 minus x3 equal to 0, then 2x2 minus 3x3 equal to 0, then x3 equal to what? X equal to x equal to 0 because 1x3 equal to 0. Then here has only a trivial solution, that means x1, but we substitute x3 here, it becomes 0, x3 and x2 here, it becomes 0. Therefore it has only the trivial solution, that is all are zeros, that is all variables are 0 here. x1 equal to x2 plus x3 equal to 0. So far we have done example problems regarding solving simultaneous linear equation, system of linear equation by using matrix method with using rank. We have done. Please subscribe our YouTube channel.